The other issue that I think is really revolutionizing how we approach patients with AML and MDS is community access to next generation sequencing. So for years, we were able to perhaps annotate 1 or 2 genes of interest. And that actually didn't give us any significant information in terms of the genomic architecture of patients with AML and MDS. So I think over the last decade, we were able basically to perform multiple studies looking at mutational patterns in this group of patients. And this actually has resulted into what I think is going to constitute a major, well, it's already a major revolution in how we approach these patients. So what we're learning from these genomic studies using next generation sequencing is, number one, that of course a number of these genes are potential targets for therapies. And indeed, this year 2 drugs were approved in acute myeloid leukemia using this kind of information. So I'm referring to mutations in FLT3, and I'm referring in mutations on the IDH2 gene. So there are 2 compounds that now you can select based on this molecular information. But what I think is more important, or as important, is the fact that we can now predict outcomes to therapy and to allogeneic stem cell transplantation based on particular mutational profiles. I think this is going to be tremendously important for our patients and the way we actually practice medicine and decide therapy with this group of patients. So let me give you an example. So for instance, in my opinion, one of the most important data that has emerged from this type of analysis is, for instance, the fact that we may predict outcomes with an allogeneic stem cell transplantation based on P53 mutational status. So now we understand that this group of patients that have complex karyotype and have a mutation on this P53 gene, they actually may have poor outcomes with allogeneic transplantation, and that is going to force us to think about new initiatives for that kind of patient. So number of mutations, specific mutational signatures may allow us to predict patients with very good prognosis, intermediate or poor prognosis, and this is going to have an impact in terms of whether we decide high-dose chemotherapy approaches or allogeneic stem cell transplant. And of course, the future is going to be as we develop more and more of these targeted precision type of medications based on this next generation sequencing. So this is a must for anybody that wants to treat a patient with AML or myelodysplastic syndrome.